it's good to see you all again. I'm Natasha and welcome back. So today we're going to start a new chapter, which is the 7th chapter, Permutations and Combinations. So, and yeah, one more thing that, actually, in the previous video, like where I've done a video on the 6th chapter, right, which is the linear inequality. So don't worry, because we'll be discussing that topic too. And so we're just moving on with another chapters also. So our today's topic is going to be related to permutations and combinations. So let's get started. Okay, so first thing, that what is permutation and what is combination. So first we'll be discussing about these two things, and so what I'll do is that I'll move on to its defines. Okay, what is its definition? Okay, so it's really simple. Let me tell you what is permutation. So permutation is just an arrangement of a number of objects in a definite order. Okay, in a definite order. Okay, so let me just tell you. Permutation. No need. Yeah, so it is the arrangement of a number of objects in a definite order. Okay, so what is it saying is that the arrangement of a number of objects in a definite order. So what we can see is that it's basically talking about the order, right? Okay, so permutation. So in permutation, order matters, okay? So in permutation, order matters. Like, it is just an arrangement of a number of objects. Yeah, and it is second thing that it is in a particular order. Okay, so let's take examples. Let's take some few examples. Okay. Okay, so for example, let's say 2, 4, 6, 8, and 10. And what is this? So it is the first 5 even natural numbers, right? Okay, so let me write this in the bracket. It is the first 5. It is the first 5 numbers, even numbers. First 5 even. Let me write this again, okay? Because that will be more better, right? Five natural numbers. First 5 even natural numbers, okay? So the first 5 even natural numbers, right? That's what we can see. Okay, so what I can see here is that it is in a particular order, right? And as you all can see this, so it is 2, 4, 6, 8, 10. So what I can see that, all these numbers are the, what I can say is that they're the, divisor or whatever. I don't know what you will say this, how will you say this, but I can just simply say that we can see the difference of 2 between all these numbers, right? I mean, on adding 2 in each number. what I'm getting is 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. Right? Plus 2. Plus 2, plus 2, and plus 2. Right? So that's what I can see here. Okay, so basically what is here is that we can see in arrangement of a number of objects and they're in a definite order. Definite, yeah, or we can even say indefinite. When what will it mean? Definite order, we're just getting this, but what will be then indefinite order? We'll discuss about that later, not now, okay? Great. So, I hope you all can understand this because this permutation topic is really easy. So, all these concepts are really easy to understand and we'll be having no confusion, nothing at all, okay? So, I hope this permutation topic is clear to you. Now, let's move on to our combination thing, okay? Yeah. What is combination? Oh, I'm pretty sure you'll be able to guess this, right? Just by hearing the name combination, what are you getting in your mind? Combination, some few things getting combined or something. This is how they're making a combination of something. Yeah, that is actually combination. It is actually related to the combination. Now let me tell you in definition. A small definition for a combination. So combination is just, like a selection of a number of objects. That's it. Selection of a number of objects, okay? Yeah, so it is a selection of a number of objects. Okay, so one thing to remember is that in permutation, order matters, but not in combination, as we don't even, think about the order, because, it can be in any order. So if I'm going to take the same example, I won't just take the same example, okay? Because it will be a little confusing, right? Yeah. So let me take another example other than this one. Right. Okay. So let me say in combination, I can take a really easy example. So it is something, selection of a number of objects, right? Okay. Yeah, so let's take something like this way, okay? 1, 2, 4, 5, 6, and 9. Okay, so what I've written here is that any 6 natural numbers. Okay, so any 6 natural numbers. So I've taken, a similar example like this one that was related to natural numbers, and this one's too. Okay, so what I can see here is that 1, 2, 4, 5, 6, 9. It is not having any particular order, and it is just a selection of any 6 natural numbers. So I can even say 100, 200, or 320, or even 23, 50, 57, anything. Because it is saying any 6 natural number, doesn't matter to the order, nothing is given to us. We have to just tell any 6 natural numbers. It can be any natural number, right? Okay, one thing shouldn't be negative, and 0 will of course not come. So, I hope this is clear. And in here we had a common thing. So here here we're seeing a common thing is that it is these plus 2 things, right? But here there is no order. So in combination, order doesn't matter. First thing to remember this about combination. So I hope these 2 topics are clear to you, and I have taken some easy examples to just tell you this, that how easy these topics are. There's nothing hard in it. It's just a piece of cake. We're actually almost eating it, but it is not finished yet. Okay, let's just finish the cake. Yeah, let's finish it. Okay, so now we'll be moving on to some questions. But yeah, before moving on to the questions, I have something else to discuss, okay? Okay, so actually it is about the fundamental principle of counting. Okay, what is fundamental principle of counting? So, it is nothing, let me tell you. It is just there are 2 principles. In first, we are seeing an addition principle, right? In second one, we will see the multiplication principle. So in first one, here we have 2 ways. Let me just tell you this in brief, because we'll not be discussing this topic today, okay? Yeah. So in this addition principle, which is the first principle. Let me write this here. Next topic is going to be on fundamental principle of counting. Okay, so this is going to be our next topic. Okay, now let me tell you, in the first principle is the addition principle. So in which, we're given a condition. So here, a condition is given to us, okay? And let's say we have 2 ways. So let's take a normal example. Suppose we have a question, and we have 2 ways, 2 methods for it. Like either we can solve it, we can solve it from the first way, or we can solve it from, we can solve this, the second one, either, okay? Yeah. So, like whether we'll be using the first method or the second method, right? Yeah. So, let's say that here questions given to us, and we have 2 ways, m ways and n ways, okay? M and n. So, here to find that, what will be our solution? What we'll be doing is that in addition principle, we'll be adding those weights, m plus n. Okay, actually I'm pretty sure that I'm not taking an exact example. I just want you to understand this thing, okay? So let's understand this, okay? It's nothing, as I just told you, that we'll be discussing this only in brief, okay? So I'm just, here taking a random example, get in my mind, So, yeah, so this m plus n ways, and so in addition principle, what we'll do is that we'll add that m ways and n ways, okay? So m plus n ways, right? Okay, now the second principle, which is the multiplication principle, okay? So in which, let's say, here also 2 ways are given to us, m ways and n ways, but in multiplication principle, we'll be multiplying those ways, right? m into n ways, okay? One more thing is that, I just again want to say this. The example's not exactly right. I'm just telling in normal thing. Like in addition principle, we'll be adding those ways. In multiplication principle, we'll be multiplying those ways. And else, whatever else is there, we'll discuss it in detail in the next video. So that's all for today. And don't worry, we will continue our 6th chapter as well, but here let's just end this video. So thanks for watching and have a great day.